Okay, hello everyone and welcome to this iniBuilds TriStar live stream version 2. This is the second live stream that I've been doing and we are going to be testing out the brand new version 1.0.1 of the iniBuilds TriStar. And I've decided to fly a little different today. We are not going to be flying Delta or any of the usuals. Rather, we are going to be flying Air India TriStar. Now, the Air India TriStar, this particular one has quite a unique story to it. It was leased by a couple of airlines actually, came to Air India. This was during a time that Air India actually was wanting to buy more TriStars. But it seems that whoever was in charge of the TriStar project at the time, he told Air India that the project is pretty much underwater because of the Rolls-Royce deliveries. Anyway, so they did get 2 TriStars at one point, and this aircraft was then withdrawn from use in 2008 and stored until the year 2019, after which it was then sunk in the Red Sea. Often they sink aeroplanes for, coral reefs and all that kind of stuff. So quite an interesting history, and really glad to be flying this in version 1.0.1 in the iniBuilds TriStar for Microsoft 2024. So what is in it for you? Well, basically, if you're new to the TriStar, this is your perfect guide. And who am I? I am Joshua757, your TriStar Whisperer, and I have had extensive experience in the TriStar, flight sim experience that is. No one can really fly one in real life these days. I've been studying manuals, in particular Delta procedures and ATA procedures, and even RAF TriStar procedures. So quite a lot of insight I've gained, which I'm going to show to you today. And this is the tutorial you need, basically, to fly the TriStar properly, okay? There are so many other tutorials that exist in the world today, and a lot of them are going to be superficial, like surface level, in accordance with publicly available sources. But when you come to me, I have more than publicly available sources. RAF training has kind of helped in that regard. So how do we fly the TriStar, basically, is the question. So a couple of things that we need to now take note of. I'm going to follow Delta procedures. The first item we're going to consider is all circuit breakers must be in. So we're truly in cold and dark today. So just checking all the circuit breakers methodically. They're all pushed in. Secondly, passenger oxygen switch should be set to manual and unlatched. This is important before applying power. We don't want the masks to drop out as soon as we apply power. So make sure it's unlatched and guarded. Similarly, weather radar should be off down here. HF radios should be off. And yeah, that's one of the considerations. Master radio switches, which are located over here, they should be set to latch. There we go, they've been latched in. Landing gear lever should be set to down, that's pretty obvious. Stabilizer trim should therefore also be set to 0. ATA manuals actually use the word full down, so difference in verbose, basically. If you're Delta, you'll say stabilizer trim 0. If you're ATA, you'll say full down. Radars off, transponder set to standby. Yep. And mechanical gear release compartment, it's not even modeled in this aircraft, so we don't have to worry too much about that. So what we're going to do now is establish electrical power to the aircraft. And just look at the chat, and hello to everyone who's here. Notable mentions are Vintage Pilot 24, Polder Pilot, Classic Pilot, and Vintage Pilots. Quite a lot of pilots actually on this chat today. And I hope you can hear me all good. And if you can't, just let me know in the chat. So the first thing we need to do is establish battery power. So coming over here to DC meters, we need to check battery volts. Oh, that's great. You can hear me. Otherwise, thought might just be talking to myself. So battery volts, 28 is nominal, 22 is minimal. If it's less than 22, don't attempt to start the battery. So battery on, it all checks out. And now what we're going to do is I'm going to start the APU. Couple more considerations is AC driven pumps should be unlatched. So make sure they're unlatched. PTUs, unlatched power transfer units. ATMs, air turbine motors, are set to off for the ground operations. And yeah, that's pretty much the considerations. Ah yes, tank 2 engine valves should be set to latch. And you might say, why does it need to be set to latch? So let me quote to you a little bit of RAF TriStar CBT training. Yeah, it happens to the best of us, I think. Vintage pilot. So basically, RAF training states the fuel supply for the APU is taken by a tapping in the number 2 engine feed pipe downstream of the engine 2 tank valve. Because of this, if the engine 2 tank valve is closed, the APU will be inoperative. So that's quite a bit of insight as to why you need to latch this in before starting the APU. So yeah, that's pretty much the consideration. And obviously on any aircraft, before you start the APU, do an APU fire test. How do we do that? We come over here, ensure that all the loop selectors are set to both. Press A and B together. And what should happen when you press A and B together is you should get the fire alarm. You should hear the bell, which can't hear at all on this aircraft. So that's something that iniBuilds they need to work on. And yep, the master fire warning is working. And there should also be a fire warning on the pilot's annunciator as far as I'm aware. So yeah, I can't hear anything actually. It's I don't think it's modeled then. I think iniBuilds has to work on that. Anyway, so that is pretty much a test, and you should be able to go bell cutout and silence those. So once that's done, we can now start the APU. So what we do is we come over here to the APU panel and we go master power on, ensure that min mode is selected, minimum mode, and now we just press start. Now what should happen in the real aircraft is first the doors in transit light should illuminate. And then after about 10 seconds, once the doors are opened, then the generator starts spinning and then you get the don't load. So this sequence is not entirely correct, and I've already written to iniBuilds about that. So the APU is spooling up, and if the don't load light still remains even after it's in the green band range, then just press stop. Yeah. That's a piece of advice. Coming over here, AC meter selection goes to APU. We'll close the field. And now we can see the output. The output is in agreement with, you know, what we want. 115 volts, 400 hertz. So now we close it. There we go. So we've closed the APU and yeah, all the lights have come on. And quite a bit of sound also. It's quite loud. Maybe I'll turn it down slightly. So yeah, that's pretty good. And what we need to do now is, in view of time, we need to then start the INS alignment. But before I do that, we're going to start welcoming passengers on board. So let's turn on the APU bleed. But before I do so, I need to do the bleed checklist. So I come over here to the engine bleed control panel, I ensure that at least 2 pack flow valves are set to open, and that's a minimum for taking on passengers, okay? But it's always recommended to do all 3. Cross bleed should be closed, isolation valves should be closed, and another thing over here is, according to RAF CBT, the pack flow control valves should only open if there is bleed air. So this is something that shouldn't open only after I put on APU bleed. So just be mindful of that. And trim air, we want that on as well. Trim air isolation and zone trim switches, they are latched in, set to open. If they were not latched in, then basically this zone doesn't get trim air. It only gets air from the cold air plenum. Okay, enough talking from me. Gonna open up the APU bleed now, and yeah, you can observe the PSI is rising, and pretty good stuff. So what we're going to do now is start the alignment procedure. So parking brakes are set to park, and let's get the alignment started. So I'm going to start the INS mode selector units to standby, like so. That allows for quick warm-up of the gyros, so putting all 3 to standby. And yeah, now we're going to enter in the present position. So coming over here to the CDU. CDU stands for Control Display Unit. I'm going to test them first, ensuring all the letters and lights are showing. And now we're going to go to present position, waypoint 0. It's in auto, this one. CDU number 2 is also in auto. We can test this one as well and put it back to present position. And CDU number 3, according to Delta, should be in manual. And we'll test this one as well, put it in position, and gonna enter in the present position. So let me see where we are basically. So we are at Mumbai Chhatrapati Shivaji International Airport, and I'm going to enter in the coordinates. North 19055, north 19055, insert, always press insert, and east 072520, east 072520, insert. So 19055, east 07252. Yeah. Okay. Next, CDU. You have to do this manually. You can't just press remote. So same thing again. North 19055, 19055, insert. East, sorry. So just clear that. East 07252. Insert. And one more CDU is left over here. There we go. So north 19055, east 072520. There we go. So with all that out of the way, we are now going to set them to align. So align. There we go. The next one's over here. And the last one over here. And then if we come over here, we can check our alignment accuracy as well. Let's go to status. And this will start counting down. And yeah, sure. Breakfast is always important. So now we're going to continue on with the second officer's panel. And another thing, once you start the APU, is then you turn on some AC boost pumps to ensure pressure. So what I'm going to do is I'm going to turn on tank 2 left and 2 right and open, not actually, yeah, that's all I need to do. This ensures positive pressure of fuel to the APU. And we're going to come over here to the EFB and we're going to load up the aircraft now. So go to, let's see, load sheet, sim brief import. So let's do that. And it's adjusted our loads. We'll have to check if this is in accordance. So total fuel 52.9. Let's see. In kilograms. Ah yes, this in pounds. So maybe I can actually set this to kilograms. If you go to the aircraft settings, set it to metric. Yeah, so fuel 24,000 kilos, cargo 5.6, and passenger weight. So actually it all checks out, and let me actually put a bit more fuel on just to stay on the safe side. Right. So the fuel has been added, and yeah, now we can proceed on with our flows. So referring back to the Delta procedures, we've already done the INS stuff. That all checks out. So what we do now is we approach the second officer's panel in a particular way, okay? We don't go top to down. Rather, we start here going inwards. We follow an inwards kind of procedure. So we go in, then we go down, and we work our way in. So let me show you how to do that. So okay, so starting off, what we do is starting over here. So we'll check our brake temperatures. It all checks out. Wheel fire test, hold A and B down together. There should be a tone. If there's not, then that's something that iniBuilds has to work on. And then you press bell cutout. And yeah, we should also check the pilot's annunciator panel. Here we go, wheel fire. So 2 out of 3 tests are working fine. Okay, back to the second officer's panel. Engine, turbine, cooling, air test. So what you do is you hold both down simultaneously and check the overheats. It should only illuminate once you hold both down. Coming over here to the nacelle pylon overheat detection test, you press test. Notice the A and B, ensure these are all set to both. Coming over here to the fire detection loop test, press A and B together, press bell cutout to silence the warning. Check the pilot's central Aural warning system, no, cautions and warning system, otherwise known as core. And there should be something here as far as I know. And yeah, also checking the fire handles have lit up for the APU, the 3 engines, and yeah, that checks out. So that's a good test for the most part anyway. Coming over here to the fire extinguisher test, what you do is you press the test button, and as you press it, you press the short, and that should cancel the warning. So that is a good test. Now, coming over here to the hydraulics, hydraulic reservoir levels are in the green band range, that's good. Air turbine motors are off. Engine-driven hydraulics are latched in. Flow bars are illuminated. case drain pump outlet lights, they are set to off. That's, I mean, they're not on. I mean, the lights out, so that's the proper way. So what we're going to do now is we're going to check our AC pumps. We're going to latch them on one at a time and latch on the PTUs as well. Also ensure the ram air turbine light is out. That all checks out. And case drain high temperature lights are out. And yeah, hydraulic pressure is rising and this is looking like a good test. If you come over here to the overhead panel, what should happen then when you put the... Also our mode selector units are showing us we're ready for nav. So let's go nav on 1, 2, and 3. There we go. So ready for nav. And also on the overhead, when you turn the hydraulics on, is 4 stabilizer in-op lights over here should cancel, and the two yaw stability augmentation system fail lights should then cancel, and the rudder limiter light should also cancel. But those were actually never modeled in the first place. Also, while we have got the test going, let me disconnect hydraulic systems C and D. And what I'm going to do now, in the essence of time, is the autopilot test. So to do that, what I'm going to do with hydraulic system A and B on is I'm going to turn on the autopilot A. I'm going to press the autopilot disconnect on the yoke. That's going to sound the Wailer for 2 seconds. Then on the AFCS warnings, it'll come command disconnect. I'm going to press the cancel button. And then to cancel the alert, you press the autopilot disconnect on the yoke once again. So let's do that now. Press the alert and then press it again. There we go. The Wailer should actually sound only for 2 seconds, so that's another thing that needs to be worked on. Okay, autopilot 2. Press the alert and then press the disconnect again. There we go, and we've cleared the warning. So yeah, that's a good test. Coming back over here, we can now unlatch the PTUs. A word of advice, don't operate AC driven pumps for more than 15 minutes. Okay, coming over here, the APU kilowatt indicator should show less than 81. That's all good. Galley bus power number 2 light should be out. And yeah, we can also automatically close the fields for the engine driven generators and the generator control breakers for automatic paralleling upon engine start. Essential bus, ensure that's set to B3. In parentheses, it's fallback G1. And yeah, that's pretty much the electric panel done. Now, coming over to the fuel panel, what we're going to do is do the fuel test. All the quantity indications should drive back to the full position. Welcome back, Vintage Pilot, and you've not missed too much. We're just doing the fuel test now and going to proceed on with the rest of the flows. Then what you would do is you would latch in. We don't actually have any fuel today in tanks 1A and 3A. We do a little bit, and if you have unwanted fuel, what you would do is you would latch the transfer pumps and transfer them into tanks 1 and tanks 3 respectively, and that happens at a slow rate of about let me see what it says. If you latch it in, it should scavenge at about 400 to 500 pounds per minute. Anyway, so again, doing the test again with the tanks 1A transfer and 3A latched in, you should also see a low quantity on these for some TriStar variants. Now what we're going to do is we're going to do a tank pump checkout. So turn on each pump, latch on each pump individually and unlatch them, observing the flow bar and also observing the low pressure fuel light goes out. You can see it over here, but it's not modeled yet. So latch them all individually, unlatch them. There we go. And now we're going to test out the gravity transfer. Similar to these, but this is a backup system, so press them on. There should also be blue disagreement lights over here, which are not yet modeled. And similarly, testing on the cross feeds. Latch them in. There should also be a blue disagreement light that temporarily illuminates. So, yeah. Refuel power light should then go off once the refueling is done. So this is also not quite right. Fuel used reset we can do over here if these counters are showing any fuel. And fuel control amplifiers ensure that they're unlatched. Basically, if you set them to override, you lose your N2 protection in case there's overheat. Fuel jettison is unlatched, and there's not too much we have to do about that. Right, coming over here, we can do our engine indication test for pressure. And this should actually drive to the 9 o'clock position, not the... Anyways, what can we do? Anyways, so coming over here, flight data recorder. If any of this was modeled, you could enter in all this stuff. Yeah, so just a heads up, shout out to Vintage Pilot 24. He actually flies the Caravel, isn't it? So a very rare aircraft, and there's basically no other simmer that does that, so it's a good thing that you do. And I enjoy your videos a lot. So coming over here to do the engine vibration test, what you do is unlatch pickup selection A and pickup selection B. Do the test like so. There should also be a filter pressure light on the pilot's annunciator panel. Then you latch system A, do the test again. You get the idea. Latch system B, do the test again. And then after that, ensure system A is latched in, because Lockheed says that system A is more reliable. Coming over here to the APU control panel, if there's any fault flags, just reset them. We also need to do our second officer's instrument light test. So testing all the lights are working, and as far as I know in the Delta manual, the wheel well fire test and fire detection loop test should not light up. So that's something that needs to be rectified. So coming over here, we've pretty much done everything with the engine panel, and now we need to do our cargo test. So ensure the detector is set to both. Do the test. And yeah, we're getting the tone. We can do tone cutout as well. So pressing this in long enough, you then come to the pilot's annunciator panel over here, and you're looking for the warning smoke. There it was. So let me do it again. So come over here, press the test button. You go to the pilot's annunciator panel as well, and you should be looking for the alert smoke. There it is. So when I let go, you'll see it disappears. It was over there. So that is the test that needs to be done. Checks out. We can do the scud test as well. The main and alternate and discharge light should come on. Similarly, we can do the smoke detection for the galley. Press test. Same thing again. Going to the pilot's annunciator panel, there should be a smoke warning, which, oh wow, isn't actually modeled yet. And yeah, then you can do tone cutout and all that good stuff. So that's pretty much the tests for the fire detection system. And yeah, humidity control, we don't need that today. Come over here to the Aural warning test. Oh, your X-plane crashed. How come? Is it because of some update or something? Or incompatible drivers or so on? So basically, coming to the Aural warning test, we're going to press the test button and test out each Aural warning. So first one is overspeed, then cabin pressure, unsafe landing, unsafe takeoff. Oh, that is strange. And then once you're done with the Aural warning test, pro delta procedure, leave it in the unsafe takeoff position, okay? Similarly, galley smoke, the test doesn't seem to be working. And slap monitor, all that stuff should be set to on, and the slat lock light should be disengaged. Right. Just checking everything. And also on some aircrafts, this slap monitor light isn't actually there. So yeah, you got to be aware of some of the differences. So coming over here to the, let's see what else has to be done. Okay, pressurization, cabin pressure control. So what I'm going to do is do the ground check, and as long as you set your cabin pressure to below airfield elevation, these should start to close, but they're not. Anyway, so set it to norm. We're going to set our altitude today. Our flight altitude is, let's see, 37,000 feet, so flight level 370. Oops, pressing the wrong thing there. So dial this up. It's pretty automatic system. Like so. Ensure cabin vertical speed is set to index normal position. And yeah, we need our barometric correction. So we can get our barometric correction if we go to the ATIS. I'm going to use a little nav map. So I'm going to type in our code, go to information, and ATIS frequency is 126.400. So come over here to our radios, 126.400.
Shivaji Airport information Charlie, 1700 Zulu. Wind tree 50 at 4. Visibility 2. Sky condition clear. Temperature 28. Dew point 18. QNH 1012. ILS Zulu runway 27 in use. Landing and departing runway 27. All aircraft read back.
Okay, so QNH is 1012.
Initial contact you have Charlie.
So just gonna enter that in. There you go, 1012 millibars. Okay, that's enough of that. And also, once you've reached your transition altitude, then in the climb out, then just set it to 2992. the next test we're going to do is the outflow valve manual test. So set them both to manual, the outflow valves. Start to close the outflow valves one at a time, like so. Observe the cabin rate of climb is also going down. The aircraft is pressurizing. There should also be this system fault light that should illuminate over here, which isn't quite modeled yet. And safety valve forward and aft light should also illuminate over here. So similarly, I'm going to close outflow valve number 2. Just observing the full travel of the outflow valve. You can see the cabin altitude is also increasing. And now I'm going to set them back to auto and watch how they spring back. So that's a successful test. And yeah, that is pretty much the second officer's... No, actually, we've got the ECS panel. So the standard procedure for the ECS panel is to set temperature selected duct monitor zone periodically and set the selector to ACM, which stands for air cycle machine discharge. Okay, this is the standard setup for these two gauges. Just like how on the Boeing 727 you've got standard setups for your DC and AC meters, like over here. Like on the 727, the DC meter should be set to TR1, transformer rectifier 1, and the AC should be set to Gen 3. Similarly, another thing I didn't do when we came to the electrics is I didn't check my transformer rectifier volts, which I've done now, and all checks out. Okay, cargo heats over here should be latched in, and these two indicators here for avionics air should read overboard, because when the aircraft's on the ground, ground sensing automatically opens the two valves. Okay, so everything has been checked. Second officer's panel. We are now going to do the captain's panel checks. And oh yeah, one thing I've not checked yet is this area overheat test. So come over here, ensure area overheat is set to both. Press the test button. Observe the area overheat lights illuminate, and coming to the panel over here, the pilot's annunciator panel, you should see the area overheat light over here. There we go. So that is a good test as well. So similarly, you would do it for both loop A and B individually and then both, but for the sake of time we're going to skip that. Right. So coming to the pilot's overhead panel, we're going to do the next part of the checks. So, advisory lights. Before we even attempt to mess with the overhead panel, we do advisory lights test. Press the test button. We're looking for all the lights to be illuminated. And coming over here, AFCS lights, they're on. Caution Aural panel is okay, and landing gear lights also, they're all set. All the lights are working, so that's a good test. We can then proceed on with the rest of the flows. So coming over here to the panel, we are going to check our active control system. Lights are latched and lights are out. Then we do the stall test. So on the TriStar 500 variant, you have to disengage the DLC and then unlatch stall warning number 2. Do the test and you should get the stick shaker, which isn't quite modeled yet. And then similarly, unlatch stall warning number 1, do the test, and then proceed on with the rest of your flows. Coming over here, pitch trim, auto throttles are all latched in to avail of the system. Mac trim, similarly, just ensure they're all latched in, all the monitoring as well. stabilizers, ailerons, and so on. Anti-skid, so what we do is we latch this in, release the parking brakes, observe the on indication, and then do the normal and alternate test, which should give a test pattern which isn't quite working yet. Automatic braking, not all TriStars have this, but later on we'll set it to rejected takeoff. Coming over here, position light is set to on, and things are getting bright outside now. So coming over here to the rudder limiter, ensure that this is latched in, lights out. Mac feel also is latched in, lights out. CVR, we can do the test. Press the needle actually isn't modeled yet, so we can't do the test. Ignition. Emergency lighting set to arm, close the guard. Standby power, what we do is we set it to the on position first. Then you come over here to the second officer's panel. Observe the standby power flow bar is automatically illuminated. And this also allows us then to check the inverter. And it all checks out. So we're going to then set the standby power back to arm. Coming over here, windshield heat should be then latched in, checked, and then unlatched. Side window heat should be latched, and the off button, the off legend is not working as of now, and when you unlatch the captain's and first officer's windshield heats, the idle legend should. Similarly, anti-icing, coming over here, we turn the manual modes latched in and do the test, and they should read open, but something that's to be modeled maybe in a future update. Coming over here, we can turn our fasten seatbelt signs on, no smoking, adjust our lighting as required, and yeah, that's pretty much the tests for the overhead panel. Coming over here to the AFCS, I'm going to dial in our initial altitude of about 10,000 feet. Like so. Now we're going to test out the AFCS. So we're going to engage the flight directors, like so. Going to engage vertical speed and heading select, and we're going to test out the flight directors. So we're going to vary our vertical speed. Observe the flight director bar should show down. Then similarly increase the vertical speed and observe the flight director bar then goes above the horizon. So that's a good test. And similarly heading select, so engage heading select, and we'll turn this to the left of our present position heading and observe the flight director bar. So that's a good test. Similarly, you could do altitude alert test, but that does not seem to be working as of now. We can also test our standby VOR. You move it to the test indication, you should get 4 flags and 4 zeros and then 4 dashes, but that's something to be modeled in a future update. Okay, it's coming down over here. We've already checked all these things, and now we need to check out the AFCS. So instrument comparator, you press the left hand side, we're looking for the warnings as well as the ATT flag on the HSI. I'll press the second test, AFCS warnings. The first officer would be pressing his as well, as the captain does so. AFCS modes. All checks out. And QNH was 1012. Decision height, I'm going to blank out for the time being. And coming over here, instrument source select should be unlatched, lights out. And coming over here, marker beacons have been tested and checked. QNH for the standby should be set to 1012. Max indicator pointer reset has been done. And brake system select should be set to normal, system B. And checking out our engine instruments, no red flags. And coming over now to the first officer's side, doing the same thing with the instrument comparator, AFCS warnings, and AFCS modes have been checked. There's also a GPWS test that you can do, but that does not seem to be modeled on the TriStar. Coming over here, we can now check out our center pedestal. This is the last check on the aircraft. So ensure pitch disconnect and roll disconnect levers are pushed in. This actually wasn't modeled initially on the iniBuilds TriStar, but it seems to have been modeled now, so that's quite nice. If you do roll disconnect, now you can only move your captain's yoke and pitch disconnect as well. So ensure that those levers are pushed in. Throttles at idle, engine fuel switches are cut out, and we can do a TCAS test as well. Which still hasn't been modeled yet. Would be waiting for the TCAS system test, okay. And yeah, similarly, roll aileron trim, rudder trim is set to 0, and that all checks out. So coming back over here to the Delta checklists, now things get interesting because now this enters the before start checks. So, but before we start, we need to enter in all our waypoints. So I'm going to set our mode selector units to remote on all three as we then enter in the waypoints. So go to remote, go to waypoint, like so on all three. And now we're going to start entering in the waypoints and change the selector to waypoint number 1. And now I'm going to refer to my SimBrief flight plan, and we're going to see what these waypoints are. Okay, so the first waypoint is north 1918-1. North 1918-1 insert, and east 072444. East 072444 insert. Okay, waypoint number 2 is, let's see, because I'm not going to enter in all the waypoints, that'll be excessive. So just checking to see which waypoints I agreed on entering. Next waypoint is MB364. No, actually that's airway. Second waypoint is, there we go, ISRIS. So coordinates of those are north 20455. 20455 insert, and east 072568 insert. Okay, waypoint number 3 is, let's see, there we go, waypoint number 3, north 21111. So north 7272111. Insert. And east 072577. 072577. Insert. So that's waypoint number 3. Waypoint number 4 is called Elmon, which its coordinates are. Just give me a moment. There we go, north 27036. So waypoint number 4, north 27036. 7036. Insert. And east 075199. East 075199. Insert. Welcome everyone who's joining the chat. And yeah, we're going to be starting the aircraft very soon now. This is the before start checks, so entering the waypoints, the takeoff performance, and then straight to engine start. Waypoint number 5 is called Ucaso, and its coordinates are, let's see, north 27383. So waypoint number 5, north 273, hang on, getting mixed up, north 27383, 383, insert, and east 075519, insert. Yeah, so that's pretty much it. 5 waypoints for this relatively short journey. And we can also check on the other side whether they've been updated. Doesn't seem like it despite being on remote, so something strange going on here. And on INS number 3 as well. Anyway, so no worries about all that. So what we're going to do is change them back to, go back to the auto position. I'm going to set this back to waypoint 1 and set these also back to the auto, and CDU number 3, set that to manual. Right, so that's that out of the way, and now we need to do our takeoff performance. So to do this, we need to enter in a GMT. So we press the arrow here, and you can enter in pretty much anything as far as I know. That then opens up the pathway to do the other stuff. So coming over here to our load sheet, gross weight is 1702. So coming back over here, gross weight 170. Actually, you can't put the 2, it's only rounds it to 3 significant figures. And fuel is total fuel 35.1. So adding that in. Fuel, you can actually put the decimal 35, hang on, 35.1, insert, and static air temperature. We'll come over here, because when we're stationary, total and static are the same. It is 27 degrees. It's quite hot actually at Mumbai. So 27, insert, and now we've got an EPR for takeoff of 0.636. And climb, we said our altitude was flight level 380, insert, and we're not going to bother too much with the other stuff. And that's pretty much the flight set up. So that's the takeoff. A couple of comments in the chat about F-16 fighting Falcon. It'd be quite interesting to see an F-16 tutorial. It's quite a cool aircraft. So come over here to the takeoff performance. It's quite a simple EFB, so all you do is sync, like so, calculate takeoff thrust 0.637, which is more or less in agreement with the EPR given by the PMS of 0.636 and initial climb of 0.491 and V1 of 134, rotate 138, V2 152, and now all we do is just set bugs and EPR. So the bugs have been set of 134 and V2 or 152 is in orange, and we've also got some flap retraction speeds. So flap retraction, flaps 10 172 and flaps 4 212, and then flaps up. Yeah, so that all checks out. Okay, so that's all the stuff done, and I'm gonna set our runway heading of 270 over here. That's pretty much all the AFCS. I'm not gonna set my V2 plus 10 over here because when we turn on the toga option, this will automatically sort ourselves out. There we go. And I don't even have to do a heading select if I wanted to, because the toga option over here will give us wings level clearance. Similarly, rad INS switches we can set to radio or INS. I'll keep them on radio for the time being. And yeah, so now we're coming to the before start checks. We've done all the flight plan, initiation, performance data, all that stuff is done. Fuel weights, all that stuff. So now is where the first officer, captain and flight engineer, they now come together and they start the aircraft. So this is where the second officer now acknowledges a couple of things for the before start. He acknowledges that he's done his warning and caution light tests, his fire test, hydraulic tests, electric tests, fuel, and so on. The second officer now acknowledges that the engine tank valves have been latched in for engine start and are guarded, and engine instruments are all okay. He then acknowledges all warning, which we did, engine bleed controls, ECS, pressurization, and so on. And then you do the cabin attendant briefing. Now, anti-collision lights at this point, they need to come on, like so. Door lights are out, and with engine 2 not operating, we need to turn on electrically driven hydraulic system B, like so. There we go, and we're ready for the pushback and the start. So engine start, what we're going to do is we're going to start on these two tank pumps, so I need to turn on the cross feeds to ensure fuel pressure, and I'm going to turn on off packs 1 and 3, leave pack number 2 on, ensure we have enough pressure for engine start, and now we're going to start the engines. So parking brake release and starting the pushback. Okay, pushback's underway. We're going to start the engines. Ignition will be set to A today, and we're going to start engine number 2 first. Okay, engine number 2 spooling up. At 20% N3, we're going to introduce the fuel. Okay, 20% N3, fuel on. And then at about 46% N3, the starter cutoff will occur, at which point the captain says starter cutoff, and then the rest of the engines are then started. There you go, starters off, and what I'm going to do now is turn off the APU air. It says do not mix APU and engine bleed air. And now we're going to cross bleed start the other two engines. So parking brakes back on. And you do need to spool up engine number 2 to about 70% N3 for this to work. Like so. And now starting engine number 1. Start valve is open. Okay, 20% N3, introducing the fuel to number 1. Also, the second officer is required to monitor air pressure as well. In case the PSI drops to below 20, you can unlatch the remaining pack, but be sure to latch it on by 40% N3. Okay, starting engine number 3 now. There we go, valve open. Also monitoring hydraulic pressure. Okay, 20% N3. Fuel is on. Okay, so what I can do now is extend our flaps. Flaps 10 for takeoff. And 46% N3, the starter is cut off. So I'm going to select engine start, set to both. Checking the overhead, I can now turn on the captain's and the first officer's air data sensor heaters. And strobe light upon entering the runway will turn on. Checking everything, all lights are off. Coming over here. Now coming over here to the flight engineer's deck. Going to check our electrics. The fields have automatically closed, but engine generator control breakers haven't. So we're checking Gen 1, 2 and 3. And now closing the breakers. Like so. Now we can turn our galley power on. So galley bus power 2 and 3 is set to on. Checking the IDG, oil temperature and rise. All checks out. Coming over here to the fuel, we can now go tank to engine. Latch all the tank pumps on. Shut off the crossfeeds. There we go, so fuel is checked. Hydraulics, set the air turbine motors back to auto. Shut off AC pump for system B. Coming over here, we'll turn on 2 packs. We'll keep pack number 1 off for the time being. And coming down over here, we can now shut the APU off. So we'll press APU stop. Like so, and allow the APU to spool down. Takes about 90 seconds and so. And then we'll shut the master power off. Right, coming over here, it's time to do the flight control checks. So the flight control checks are quite interesting. First you deploy the spoilers. So you're deploying the spoilers, they've been checked. And now we do our flight control checks. So we do full left, full control deflection to the right, neutral checked. We do full control deflection to ensure that the spoilers actually stow, and now full down, neutral, full up. Flight controls are checked. Stabilizer trim was, let's see, what, 3.59 for takeoff. So I'm going to introduce that. There we go. Stabilizer trim set for takeoff, flaps and all are set. And yeah, alpha heats and yes, wings, windshield heats, that all was already latched in. There we go. That's all checks out. Altimeters, airspeed indicators all in agreement with each other. And yeah, now we're going to start the taxi. So parking brake release. And let's start making our way towards the runway. Trying to figure out how to get there. So consulting with little nav map as well, see how to get to the runway. You can also turn on the taxi lights, landing lights and so on. I'll turn the strobe on from now so I don't forget. And also now is a good time to set our auto brakes to rejected takeoff. Also looking at the central cautions and warning system, there's no alerts over here. On the real TriStar there should be one more alert, which says electrical system, because now I have to turn off the APU master power since it's cooled down sufficiently. So there we go. Okay, so we're going to turn ourselves onto the runway, so I'm going to alert the flight attendant. Going to engage Toga as well to provide flight director guidance. Also going to start the chrono as well, keep track of time. Okay, we're lined up at the center line. I'm going to engage takeoff thrust now. 0.637 EPR. You can see the engine to fail has armed itself. Okay, 80 knots, 100 knots now. V1. Okay, let's rotate.
Positive rate of climb.
Positive rate, gear up.
Gear up.
Just following the flight directors. Let's engage climb thrust, 0.491. Also, at 2,000 feet, you do the acceleration. That's how it works in Mumbai. So we're going to accelerate. Let's retract the first stage of flaps.
Flap 0.
Okay, landing gears up. We can turn it back to neutral. Like so. Flaps up. Now we're just going to pitch for 250 knots. Going to attract the landing lights, all that stuff from now. Okay, coming up on 250 knots, I'm going to engage IAS hold. Also, let's go to INS on both sides. And let's turn now towards the first waypoint. Also, let's engage the Autopilot. Okay, so after takeoff checks, landing gear up, lights off neutral, flaps are up. Also, transponders should be set to TARA. Coming over here, we can restore our pack flow. So we'll turn on pack number 1. Pressurization is normal. Let's also see if thrust management works. So let's engage thrust management. Let's set ourselves to 0.512 EPR. That's the climb thrust. It should be 0.63. Hang on. Climb 0.512. And we can also go VNAV as well. It'll maintain 250 knots until 10,000 feet, after which it'll then accelerate beyond. And let's also follow our INS. Let's check our mode selector unit. Let's go to distance. I think the INS is not working, unfortunately. It's not even showing our ground speed. Okay, so in spite of having entered all my coordinates, the INS is not working. So I'll have to fly pretty much manually via heading select. Okay, altitude alert, 1,000 feet. 1,000 to go. Let's reset our altitude to our cruising altitude. You can already see climb thrust has been set. So I'm going to fly VOR to VOR in this instance, so I'm going to set the closest VOR to our waypoint and we'll follow that. So the closest one is 113.30. Center the course deviation indicator and now we'll follow that. We can now turn off the fasten seatbelt sign as well. Coming over here to the flight engineer's deck, we can check a few things. Check our fuel, electrics, all okay, hydraulics. Okay, so the chat is in agreement. We're going to do a cabin tour. So let's do it. So let's get out of the cockpit door, and quite a nice spacious cabin actually. There's a lavatory door over here, and quite a large exit door. I know Lockheed had done quite a bit of work in making these exit doors, and quite spacious there as well. There's some equipment here for the flight attendant. There's a phone. And nice cockpit door. Overhead lighting. And there's some Coca-Cola over here. And now checking out the cabin. So the cabin is, let's see, 7 abreast heating, so 2 seats over here, 4 seats, 3 seats in the center, and another 2 seats. If you come over here, you can see the L-1011 engines, and quite spacious actually. There's no overhead bins for the center, so it does give the cabin a very spacious approach. Also, you can see there's these projector screens over here, 3 CRT projectors, which would project movies at every interval. So this is really spacious, the cabin. And let's go more to the back. So this is definitely the first class because the seating is much more nice, the detail. And coming to the economy, it's 1, 2, 3, 4, 5, 6, 7, 9 abreast seating, so 2, 4, 3 arrangement. And same thing again, projector lights. You can also see the no smoking is still illuminated because I didn't cancel it. So if I come back to the cockpit here and I cancel the no smoking, and let's go back to the cabin. You can see the light is extinguished, so the cabin is actually well modeled. I think this was the main focus of the add-on. More cabin modeling and less cockpit systems detail for the time being. You can see the wing and the detail on the wing. You can see the S-Duct. So the cabin view actually allows you to exit the aircraft. So you can see the S-Duct, you can see the Air India Palace windows. I think the view actually looks more impressive from here. You can see the Air India livery. Looks really nice. Yeah, so good question in the chat. What do you think of the update? Well, the update has actually been quite minimal. I'll put it that way, okay? I'm the kind of simmer that gives you a no-nonsense a no-nonsense review. So although the change log is really large, you know, if you go on the website, there's quite a large change log, quite a lot of features and fixes, but from my point of view, the fix is minimal. It's a minimal fix. Yeah, the Autopilot is still quite strange, isn't it? Okay, so back in the cockpit and climbing slowly. I've increased the sim rate a little bit to get to the destination quicker. And just want to complete the cabin tour, go right to the back of the cabin. If only there was a faster keyboard way of doing this. If anyone has any questions, any requests as to what they want to look at, or, you know, just let me know in the chat. So coming right to the back, and this is the interesting part. Most of the streamers, they get stuck down here. And yeah, they come over here to the toilet and then they spend like half of the stream trying to open the toilet doors, just only to find out they don't open. Or do they open now? Nice, so now you enter the toilet and you have the engine behind you. So you got a question in the chat. Is the pressurization working? Let's have a look. Right, so coming over here, we are getting a bit of cabin climb. I mean, now we've leveled off. Cabin altitude is 8,000 feet, and PSID differential is what's on the... Actually, hang on. The inner dial is differential pressure and the outside is cabin altitude, so about 7,000 feet. Also above our transition altitude, I should have set my my barometric correction back to 2992, like so. And yeah, now let's check the bleed logic, okay? So oh, that's a real shame, Vintage Pilot. Looks like X-Plane doesn't want you to fly today. So coming over here to the engine bleed, let's now check this against real... That's okay. You have to obviously concentrate on the F-16. It's quite agile, you know, it's not like slow moving like this, isn't it? Okay, so actually before I start doing stuff, let's tune into the next VOR. So 113.20. Actually, it's probably too far out. Let's try a closer VOR, 115.90. The INS is still not working, so... That's the disappointment, basically. So basically, I wasted my time doing the INS and then entered all the waypoints and found out it's still not working. So that's the annoying aspect of this. So while everyone's here on the chat, I want to explain about the pressurization. I mean, not the pressurization, the engine bleed control. So what I'm going to show you now is a snippet from actual RAF L-1011 CBT. I'm going to show you the position of what these should actually be, and we're going to compare those. Okay, so coming over here to the OBS. Here is the actual snippet from the CBT, which tells you the position of the ram air turbines and the turbine bypass valves in flight and on the ground with packs on and packs off. So with packs on in flight, basically over here, so packs on in flight, the turbine bypass valves should be modulating in their full position, which if we come over here, it should then modulate throughout its entire position in the flight, and the ram air louvers should be at the 1/3 open position. So coming over here, the ram air turbines, these are pre-programmed positions, so it's not quite right. It should be in the 1/3 open and modulating. So something is not quite right about these ram air turbine and ram air louvers and turbine bypass coolers. And similarly, if you shut the pack off, if you look at the CBT with packs off, it should be in flight. The ram air louvers should assume the 1/3 open position, which they have not, and the turbine bypass should assume the 1/3, the 2/3 open, sorry. Which, if we compare that now to the game capture, it's completely wrong, basically, you know. So that's the problem. If you compare the CBT of the positions with the actual, with the pack off, it should be the ram air, the turbine bypass should be in the 1/3. But over here, it's the total opposite. Basically, this is the issue. This aircraft is... the modeling is quite insufficient. Similarly, another thing that should happen is if you were to shut off packs 2 and 3, because they are the ones that supply hot air, this should also then shut off the hot air and hot air isolation as well. You know, so that is something that's not yet modeled. Say if you shut off pack number 3, it should then shut this off and shut this one off automatically. And then if you reinstate pack number 3, it should then, you'd have to cycle these to get them back on. So there's quite a lot in terms of the engine bleed control panel that is kind of modeled incorrectly, and a lot of attention needs to be at this. Let's see if we can get to the other VOR, 113.20. There we go. Let's also... Oh, quite a insightful paragraph from Super 6 CEO. Let me read it out. In the Super 6, in brackets DC6 Series B, the cabin is pressurized by engine-driven superchargers that pump compressed air into the cabin. As it is a piston engine plane, it does not have bleed air. Wow, that's a very insightful comment. And actually chat replay is on, so other viewers will be able to see this comment. Yeah, it's very good. What are engine-driven superchargers, if you don't mind me asking, for the benefit of everyone else here? We got a request earlier on from Crispy Landing. Is the lower galley modeled? Let's have a look. I didn't actually see it. I don't know where to look actually, because I've not actually been obsessing too much about the cabin. Been more interested in the cockpit side of things. But if you could point me out where it should be, could have a look for it. Is it like a staircase or something you have to go down? I think so, right? I'm not sure actually where to find this lower galley. Sorry about that. Basically like a supercharger that gives the engine more power. Instead, it's powered by the engine, and the air, instead of going to the engine for more power, it goes to the air conditioning. Oh, okay. Yeah, you're probably right. It definitely was not on other TriStars. I think as of the 1990s, they started to prioritize, you know, cargo instead. So I think even TriStars that had a lower galley, they got them removed, if I'm not mistaken. So let's see what other VORs I could go towards. Because the thing is, I put all the INS coordinates and it didn't work, so what to do? Could actually go to the Jaipur VOR, so 112.90. Let's go back to heading select first. There we go. Now I'll adjust the course. Now go back to VOR. How many seats, you ask? Let's see. Okay, so let's check out how many seats there are. So the first part of the cabin was... It didn't have 9 abreast, it had 7 abreast seating, okay? So 3, 4, 5, 6, 7. So now we need to see how many of these rows are there. Oh, actually there's 3 seats alone. Okay, so let's start counting how many seats we got. So you got 3 plus 7. Hang on. 7, 14, 21, 28, 35, 42, 49, 54, 63. So 3 plus 63 is 66 in first class, and then we'll check out the rest of them. Okay, so we have a standalone 4 seats in front. So plus 4 is 70, and from now on it's 9 abreast seating. Actually there's another 4 standalone seats. Actually, hang on, 3, 4, 5. Okay, so add 5, 75. Plus 9, 18, 27, 36, 45, 54. 54 is here, 63, 72, 81, 90. So I'm going to add on 90 to the calculation. Plus 9, 18, 24, 36, 45, 54, 63, 72, 99. So my rough estimate is about 264 seats. Okay, so what I'm going to do is I'm going to start my descent. Let's go to about 20,000 feet. I don't want to be rushing towards the end. And yeah, let's go to what's the optimum speed right now? If we go to climb, actually cruise, sorry. Optimum is still Mach 0.8. At 285 knots. So let's do IS hold of 285 knots. So I'm gonna go IS hold. And let's reduce power now, slowly. Okay, so you got a question in the chat. How was the update? The update, in my opinion, is quite minimal. Okay, altitude alert. Capturing our altitude. Actually, let's continue descending, so let's go to about 10,000 feet, because we're coming quite close now. And sadly, I don't have any charts to help me out, other than little nav map. Okay, so turning back towards our waypoint. Just using little nav map because, you know, the INS isn't working. You can extend a bit of speed brakes if you want. So actually, IS hold actually doesn't work very well as of now. Okay, so let's get some airport information for our arrival. That's a good question about the DC-8. Yeah, so the DC-8, it doesn't use spoilers in flight because it's actually prohibited. It produces unstable characteristics, so that's why it's not even allowed to use in flight. There was one Japanese Airlines flight, if I remember correctly, on the DC-8 Super 63, or I think it was 61 actually, where instead of retracting the landing gear, the pilot actually retracted the... He actually extended the spoilers. And this was upon takeoff, and the aircraft had stalled and it crashed. And that was just one example. But they did testing, and basically you can't use the spoilers. They don't produce stable characteristics, aerodynamic stuff. So you have to use the inboards number 2 and number 3 TRs, thrust reversers.
Shivaji Airport Information Delta 1900 Zulu. Wind calm. Visibility, tree. Sky condition, few clouds at 1700, few clouds at 4700, few clouds at 13800. Temperature, 20. Dew point, 10. QNH 101 tree. ILS Yankee runway 09er in use. Landing and departing runway 09er. VFR aircraft say direction of flight. All aircraft read back hold short instructions. Advise controller on initial contact you have Delta.
Okay, so we're going to be using runway 09.
Delhi Airport information, Charlie. 1900 Zulu. Wind 259er at 7. Visibility.
I'll tune it over
Sky
here.
condition, clear. Temperature 18. Dew point 12. QNH 1015. ILS runway 28. ILS runway 29er right. And ILS runway 29er left in use. Landing and departing runway 28. Runway 29er right. And runway 29er left. All aircraft read back hold short instructions. Advise controller on initial contact you have Charlie.
Chhatrapati Shivaji Airport Information Echo 1900 Zulu. Wind calm. Visibility, tree. Sky condition, few clouds at 1700, few clouds at 4700, few clouds at 13800. Temperature, 20. Dew point, 10. QNH 101 tree. ILS Yankee runway 09er in use. Landing and departing runway 09er. VFR aircraft say direction of flight. All aircraft read back hold short instructions. Advise controller on initial contact you have Echo.
Delhi Airport information, Charlie. 1900 Zulu. Wind 25.
Chhatrapati Shivaji Airport Information Echo 1900 Zulu. Wind calm. Visibility, tree. Sky condition, few clouds at 1700, few clouds at 4700, few clouds at 13800. Temperature, 20. Dew point, 10. QNH 101 tree. ILS Yankee runway 09er in use. Landing and departing runway 09er. VFR aircraft say direction of flight. All aircraft read back hold short instructions. Advise controller on initial contact you have Echo.
Delhi Airport information, Charlie. 1900 Zulu. Wind 259er at 7. Visibility 1. Sky condition clear. Temperature 18. Dew point 12. QNH 1015. ILS runway 28. ILS runway 29er right and ILS runway 29er left in use. Landing and departing runway 28. Runway 29er right and runway 29er left. All aircraft read back hold short instructions. Advise controller on initial contact you have Charlie.
Okay, so little nav map tells me that I should be slowing down to about 230 knots now. So let's do that. Can also compute our landing data. So if you come over here, landing performance. Let's see. Actually come quite close, so let me do that now. Landing weight is... Let's get it from the performance. Landing data, gross weight 161. And let's see our load sheet as well. Yeah, it's actually, it aligns quite well. 161. And landing elevation, let me just check that out. 749 feet. And dry anti-skid is on. Let's calculate that. So we got flap 0, speed of 207 knots. flaps 4 187, and yes, let's set these bugs now. And V approach 152, VRF for 147. Okay, now I need to start descending to about 3,000 feet. And let's try a IS hold descent, so let's reduce our power.
Flaps 4. Flap 0. Flaps 4. Flaps 10.
$2,500.
Hey, welcome back. So you're just in time for the landing then. Okay, so we're coming to intercept the localizer, so let us now prepare for the landing. I'm going landing gear down, and I'm going to start deploying flaps. And let's continue our descent to about 2,500 feet. Let's go vertical speed. And let's start slowing down to the landing, approach 152.
Flaps 14. Flaps 18. Flaps 22.
There we go, approach 152 knots. And then I can go flaps 30 and get the DLC out. Let's go flaps 30.
33.
1,000.
Okay, so I've landed. I tried turning off a little too soon, but the nose wheel steering was a little bit compromised. Turn the auto brakes off now. And gonna check the flaps.
Flap 0.
So what I can do if I want is I can shut down the number 2 and number 3 sorry, number 1 and number 3. And taxi on engine number 2. And to do that, I have to turn on the PTUs for that to work. And we can also get the APU started since we vacated the runway. So let's get the APU going. She looks like we'll have to find somewhere else to park. It's so crowded actually over here. Didn't really plan where to go. Actually, I'll go over there next to the GA aircraft. It's kind of crowded over here. Okay, let's stop over here. And I think that's quite enough flying for today. Let's shut off the remaining engine. Keep the pack though latched in. Now we can turn on the APU bleeder. Okay, so that's pretty much it. Let's get the fasten seatbelt signs off. No smoking. Let's get the probe heats off and the windshield heats. And yeah, it's obviously need to turn our mode selector units back to off. And yeah, that's pretty much it actually. And gonna conclude the live stream over here. And thank you everyone for joining me. Today was quite a long live stream, probably one of my longest. We did a very thorough startup of the L-1011, exploring all the stuff, and quite a lot of cabin overview as well this time. And quite a foggy landing, like couldn't even see where I was going right till the very end. And finding place to park at Delhi is quite difficult. So see you again for another TriStar adventure. Maybe we'll do a RAF TriStar next time, or perhaps we'll do some other aircrafts and just keep it unique, you know. So thank you for joining me today, and we'll see you soon.